Well, here's another math video, and in this video I'm going to be explaining the multiple divisibility rules that are there. So divisibility is, checking for divisibility is basically the process of using different methods to see if a number is divisible by a certain number. And as you can imagine, this can be extremely useful in certain problems and situations in math questions. So here's a few of the most well-known, and as well the few lesser known ones like 7 and 11 and others. So let's get started. 1. Really, I don't have to explain this. Everything's divisible by 1. 2. The number is even or ends in an even digit. Number 3. You have to add all of the digits, and if these digits add to a multiple of 3, then you know that the entire number is a multiple of 3. So this is extremely handy. So then number 4 is if the last 2 digits are divisible by 4, then the entire number is divisible by 4. This actually works because every 100 is divisible by 4. Since 100 is divisible by 4, 200 has to be divisible. 300, 400, etc. all have to be divisible by 4. And so if you take the last 2 digits of a number, which excluding the 100s, excluding the hundreds place and everything beyond it, if the last 2 digits also comply with the hundreds digit in being divisible by 4, then the entire number will be divisible by 4. And 5 ends in 5 or 0. This one's easy. Pretty much everyone knows that one. And then 6. There's no proper way to do it, except the easiest way is basically just to check if it's even and if the digits sum is divisible by 3, which is basically a combination of the divisibility rules from 2 and 3. So if it's divisible by 2 and 3, and then 7. Okay, actually I'm going to go to the next. I'm going to refresh the page because this is extremely interesting. So the divisibility rule by 7, bear with me here. You take the last digit of a number, of the number that you're trying to prove is either divisible or not divisible by 7. You take the last digit, double it, and then subtract it from what's remaining. And then you keep doing that until you have a clear multiple of 7. And if you do, then the whole number is divisible by 7. But if not, then it's not divisible by 7. Let's give an example. 5,292. I don't know why, I just like this number. So you double the last digit, which is 2. And then 2 doubled is 4. And then you subtract it from the rest of the number, which is 529. So 529 minus 4 equals 525. And then you double the last digit again and subtract it from what's remaining. 5 times 2 equals 10. Subtract it from 52. 42, and then 42 is divisible by 7. That means 5,292 is also divisible by 7. 8. So the divisibility rule for 8 is that if the last, this isn't very useful, but you could use it. If the last 3 digits are divisible by 8, then the entire number will be divisible by 8. You will also notice that this is similar to number 4, divisibility rule number 4. So this follows the exact same logic, except 100 it's not a multiple of 8. So rather it's 1,000. 1,000 is equal to 8 multiplied by 125. So 8 is a factor of 1,000, which means that it follows the same logic as number 4. Every digit excluding the thousands digit, if that's in compliance, divides by 8, then the entire number divides by 8. So that works. Then 9. 9 is exactly the same as 3. It's exactly the same because you basically just add the digits. And so, yeah, you just add the digits, and if it's divisible by 9, then the entire number will be it'll be divisible by 9. And then there is divisibility by 10, which everyone knows, if it ends with a 0. This is probably the most simple one. Besides 2, 5, and 10 are by far and 1, of course. They're the easiest ones. And now number 11 is also quite interesting, actually. So what do you do for number 11 is, one second, let me try and remember. Okay, so you sum all of the odd number digits, and you subtract that from the sum of the even. You subtract the sum of the even digits from the sum of by even and odd, I mean okay, let's just take a multiple of 11. Let's do 11 multiplied by 47. Let's take 517, for example. And there's an extremely easy way of multiplying by 11 as well. That's going to be in this video right after this. And so let's take 517. This is an odd, even. This is the odd, even, odd, let's say. And so you take every alternating digit. Let's call these A digits, and let's call these B digits. Let's add 5, and let's add all the A digits and all the B digits. And then you subtract the B digits from the A digits, which means 12 minus 1 equals 11. And if the resulting number is divisible by 11, that means the entire number is going to be divisible by 11. Let's try another one. Let's take 69,916. So this is A, B, A, B, A. Let's add 6, 9, and 6. 6 plus 9 plus 6 equals 21. And the 9 plus 1 equals 10. And then 21 minus 10, as you can see, it's 11. This always works. I'm not actually quite sure why, but it does work. Then I think there's a 12. I'm pretty sure there's a 12. Divisibility by 12 is it's just 3 and 4. Just check if it's divisible by 3 and 4, and then it must be divisible by 12. This also works. Divisibility by 15, 3 and 5. And then I believe divisibility by 18, divisible by 2 and 9. The factors, 20 is obvious. It has to end in 0, and the tens digit has to be even as well. And then there's no, as far as I know, there is no real way to do the prime divisibility rules for prime numbers in the any other prime numbers in the tens, which are 13, 17, and 19. 11, I don't know why 11 works, you can look that up. And now we are going to get to the multiplying by 11 part. The multiplying by 11 is really cool. So let's say we have, let's go back to our, 47, let's start with something simpler. 32. If you multiply 32 by 11, all you do is take these two digits, add them. You get 5. That means 32 times 11 equals 352. Let's do another one. 41 times 11 equals, the middle digit is always going to be the sum of these two, so that means it's going to be 451. This always works. I may post another one if I find out the ones for 13, 17, and 19, and if I also if I find out why 11 works as well. And then there's another trick for 11, and you have to be careful with this. Let's go back to 47. instead of putting 4117, you actually you take the 1 and then you carry over the other 1 into this place, and so then it becomes 517. It just carries over into the next place if it's a 2-digit number. So that's all for this video, and well,